Hello, Accelerated 7-8 students. We are still working in Module 11, and this is going to be Lesson 10. So Lesson 10 is called Checking for Identical Triangles, page 80 in my comp book. I am trying something new today, and I definitely would like your feedback as soon as we finish. And what is new is I have decided that I'm going to try to type our notes on the computer and do it that way so that you can read them more comfortably. So that's what we're looking at as far as looking at the notes today. Again, this one is called, sorry, trying to find it. This one is called Checking for Identical Triangles. So here's our iPad, and this is what you guys are going to write inside your notes. It's a little bit different than in the book. I tried to keep the colors the same, but I'm thinking that this will help with people being able to see a little bit more easier because it's typed handwriting instead of mine. So checking for identical triangles. The goal for today. Today we will practice the conditions of identifying unique and identical triangles and write viable arguments about how and why they are identical. That's a long goal. Okay. Practice the conditions of identifying unique and identical triangles. That's one. And then write a viable argument of how and why they are identical. It's truly not that hard of a goal, but it's multi-layered. The question that I want you to be thinking about in this lesson is, how do you determine the kind of triangle that you are working with? Okay. A really big thing to keep in mind that could be very helpful when trying to figure out what type of triangle you're dealing with is the 6 conditions for determining a unique triangle. We have covered all 6 of them in our previous lessons. You have examples of them in your comp book that you can go back and look at. Just as a quick review, let's read through them together. So we have the three sides condition. Okay, remember the 3 sides condition is when you are given the 3 sides and they can only be those 3 sides. Okay, so that's the 3 sides condition. The 2 sides and an included angle condition. Okay, so again, remember we're going to go back for a little bit of a review. The given information is what is so important. If you're given 3 side lengths, then that's the 3 sides. If you're given 2 side lengths and an included angle, you need to remember that you have a side length and then the same vertex as the other side length, and the angle sits between those 2 side lengths. 2 angles and an included side means that you have an angle on this side, right here, and you have another angle on this side right here, and they are connected by this given side. So you're given this information, you're given this information, and then you're also given this length right here. Okay, so that's that one. 2 angles in the side opposite the given angle condition, which we drew. That's where you had to use your transparency and you had to draw the angle and then you had to turn it and twist it and move it around until it sits where it's opposite. The 2 sides and the non-included angle meant that, okay, you're given this side, here's the vertex they share, here's the other side, and then you had to make an angle that was given right here. So you were given this length, you were given this length, and you were given this angle, and it's not included, so it sits outside of the vertex. Okay? And then the last one is your measurement conditions. The measurement conditions were that a triangle always adds up to 180 degrees. So as long as your 3 angles add up to 180, you know it's a triangle. The other measurement condition was that the 2 shortest sides of the triangle, when added together, are longer than the 3rd side. So if any of these are unclear to you yet, or if you're hesitating because you don't remember, you don't understand, that's why you have your comp book, so that you can look back and check. Okay? That's why we always keep really good notes to help us. All right, so now we're going to remember these, and using these up above, we're going to do what this says. So it says, try this. State whether the triangles are identical, not identical, or not necessarily identical. If the triangles are identical, give the triangle condition that explains why, and write a triangle correspondence that matches the sides and the angles. If the triangles are not identical, explain why, If it's not possible to definitively determine whether the triangles are identical, write the triangles are not necessarily identical and explain your reasoning. So this is all about explaining why you think it is or why you think it isn't. So here's the first example right here. So we have these two triangles. They were given to you. No other information is given. So your job is to look at these two triangles and decide what you know. So we know that this triangle is called ABC. So we have triangle, and remember we're writing the notes, and the order of your vertices is very important. So we have triangle ABC. As then we have to look and see if it's similar or if it's congruent, which means if they're unique or non-unique, okay, to this one. So this one says triangle XYZ. So let's look at it really quickly. The A has an angle given. And then over here, we have the Y has the angle given. Then we have the Z has another angle given. And the Z has another angle given. And then we have a side in between the two given angles. Do we have that on both triangles? And if you can say yes, then you know that these are unique identical triangles. Okay? Remember, state whether the triangles are identical, not identical, or not necessarily identical. So I would say on this one, the answer for this would be identical, because you're supposed to state whether they are, right? And then it says, if the triangles are identical, give the triangle conditions that explain why. Okay, so we know they're identical. The condition that tells us is two angles, I apologize, two angles and an included side. And that is one of the conditions. If we look back up here, it says right here, two angles and an included side. So we know it's right there. Okay, so there's the condition. And then the last thing says, write the triangle correspondence that matches the sides to the sides and the angles to the angles. Okay, so we know that triangle ABC corresponds with triangle. Look at A. What does A correspond? Y, X, Z. Why is that? Because the A matches the Y, the B matches the X, and the C matches the Z. So this is the last part that you had to do. This is kind of squished, I apologize. So you tell whether they're identical or not, you tell the condition that proves it, and then you write the correspondence. Remember, correspondence is when you put the arrow between them saying that this A corresponds to Y, B corresponds to X, and C corresponds to Z. So that's how you choose your correspondence. Okay? Then you're done. That's all you had to do. Okay, let's try another one. I have another one for you. Here you go. All right, so let's look at it. We have triangle DEF, and we have triangle GHI. We have to decide which one is which. Okay, so in this one, we see one angle is given, one angle is given, one side is given, one side is given, another side is given, another side is given. So if we go back up to our conditions, it says two sides, and is the angle included? Yes, it is, because there's the common vertex that they share, and the angle sits between the two given sides. So we found the condition. So the condition would be two sides and an included angle. So on this one, you're going to write identical. Okay, they are identical. The condition that proved it was two sides and an included angle. Okay, and now we have to do our triangle correspondence. Our triangle correspondence, we have to be really careful. I'm actually going to say it's triangle EDF is corresponding to triangle. Where did I start? I started on the vertex that has the single slash, so the vertex that has the single slash on this one is I. So it would be I corresponds to E, G corresponds to D, and F corresponds to H. And then I have that one done. Okay? All right, this is getting easier. I think you guys are understanding it. Okay, there's one more. Let's find it. Here it is. Okay, I'm going to make you do that one by yourself, so look at it really closely. I could try to make it bigger. Let's see if it'll still fit. Ooh, check it out. That's really cool. Okay, I want you guys to take a look at that and decide, are they identical, not identical, or not necessarily? Not enough information to choose. Okay? So remember, you have to tell me identical, not identical, or not enough information. If they're identical, you have to tell me the condition, and then you have to do the correspondence. Okay? So I'm going to check this one in class tomorrow. That's all we have. All right, let's go back to our goal really quick. Hopefully that was long enough. If not, you can go back and pause it. Our goal. Today we will practice the conditions of identifying unique and identical triangles, which we just did. Write a viable argument, which we did, and how and why they are identical. So by saying identical, telling the condition that it is, and then the correspondence does all of that for us. Question. How do you determine the kind of triangle that you are working with? By using that's right, 6 conditions. Okay? So hopefully you don't have any other questions with that. Hopefully you like this and this is fun, but this is what we're doing today. That's all I have for you. All right, I'm taking off. See you all tomorrow.